This is part 2 of the review sheet for test number 6 in Calculus AB. We've got two things going on here. We're going to have to use U substitution, but we're also using the first fundamental theorem of calculus because we have boundaries. So not only will we have to use U sub, but we're going to have to plug in the numbers at the end to solve. So for the U substitution part, my U is going to be 1 minus x squared. The derivative of that is negative 2x dx. That doesn't quite match the x dx I have, so I have to divide both sides by negative 2. And I get negative 1/2 times the integral from 0 to 1 of the square root of u du. So my x dx got swallowed up in the du and the negative 1/2, and I changed the 1 minus x squared to u. Square root of u is the same thing as u to the 1/2. Now I add 1 to the exponent, gives me 3/2. Divide by that number, gives me a 2/3 out front. And so from here, I need to go ahead and simplify those coefficients and plug my u back in. So I get negative 1/3 times, remember my u was 1 minus x squared. I'm going from 0 to 1. Now, I need to plug in 1 and then plug in 0. So I get negative 1/3 times 1 minus 1 squared to the 3/2 minus negative 1/3 times 1 minus 0 squared to the 3/2. So we end up with negative 1/3 times 0 to the 3/2 plus 1/3 times 1 to the 3/2. So we just end up with 0 plus 1/3, which is 1/3. So again, we take the antiderivative, in this case using U substitution. Then we plug in the top number minus plug in the bottom number, and then just go from there. Okay, next up, we're given an integral. It says given this integral, find the derivative. Anytime you're asked to find the derivative of an integral, that's the second fundamental theorem of calculus. So this one is as simple as taking the x and plugging it in for t, meaning our answer is 4 minus x cubed. Anytime you're asked to find the derivative of an integral, you use the second fundamental theorem. Okay, same thing here. We're given an integral, asked to take the derivative of it. So I just plug in the x and I get 4x squared minus 7. Okay, number 14 says find the average value of the function. To find the average value, you do an integral over the interval, in this case 0 to 3. But then you have to divide that interval or integral by 3 minus 0, because that's the width of the interval. Sorry those words are so similar, I didn't pick them. So you basically do the first fundamental theorem part first. You do the integral from 0 to 3, but then you have to divide by 3 at the end. So it can also be rewritten this way, which I find a little easier to manage most of the time. So we'll be doing 1/3 times, the antiderivative would be x cubed minus 2x. Then we plug in the top number minus plug in the bottom number. Well, if we do that, we're just going to get 0. So I guess I had a little too many parentheses. Anyway, didn't need all those. I get 1/3 times 3 cubed is 27 minus 2 times 3 is 6. So we get 1/3 of 21, which is 7. So the average value is 7. 21 is the total area under the curve, but to find the average we have to divide by the 3, so we get 7. Okay, same process here, find the average value. So we do the integral from 1 to 5 of 2x cubed, and we divide the whole thing by 5 minus 1. So I'm just going to write that as 1/4 out front, because we're really just dividing by 4. 2x cubed dx. So I get a 1/4, just rewriting this. The antiderivative is going to be 1/2 x to the 4th from 1 to 5. So I'm going to go ahead and combine those and get 1/8 x to the 4th. You can wait and do the 1/4 at the end if you want. It makes no difference if you put it in now or later. But we got to do this from 1 to 5. So we get 1/8 times 5 to the 4th minus 1/8 times 1 to the 4th. Let's see what that gives us. We get the number 78. So we get 78 as our average value. 16. Okay, once again we're being asked to take the derivative of an integral. So we take the x cubed that's inside and we plug it in for t. So we get x cubed to the 6th minus x cubed being cube rooted. So I plugged the x cubed into both of these t's, then I multiplied the whole thing by the derivative of x cubed, which is 3x squared. So that's going to simplify to be x to the 18th, I multiply the 3 and the 6, minus x times 3x squared. If you want to simplify from there by distributing, you can. Either way is fine. Make sure, if it's not just x you're plugging in, you multiply by the derivative of it. When it is just x, the derivative is just 1, so it's not a big deal. But since we have x cubed, we have to multiply by this derivative, which is 3x squared. 17. The integral of -4 secant x tangent x. Well, you should remember your rules. The integral of secant x tangent x is just secant x. So we just stick the -4 out front, and don't forget to put plus c. If it helps you, you can have a step in between here where you basically pull the -4 out front, and then just know it sticks around, and then the rule for secant x tangent x is secant x. Okay, 18, same thing, we're just applying the rules. The antiderivative of sine is negative cosine, so the two negatives cancel out and make it a positive. The antiderivative of cosecant squared is negative cotangent x. And don't forget, plus c. Okay, here we're going to have to use u sub because we have a 4x inside instead of just x. So u is equal to 4x, du is equal to 4dx. We have no 4, so we have to divide that over. And we get 1/4 times the integral of sine u du. So that's negative 1/4 cosine of u plus c, or negative 1/4 cosine of 4x plus c. Okay, this is another one where we'll have to use u sub. This is not going to allow us to choose a basic rule. There's no basic rule for cotangent cubed cosecant squared. But I'm going to choose my cotangent as u, because the derivative of cotangent is negative cosecant squared, which is nearly a perfect match for this part right here. I do need to move the negative over by multiplying or dividing by -1. Either way, it's the same result. So I'll get negative u cubed du. Now I'm getting u cubed because I only took the cotangent out. I didn't use the cubed as part of my u. Remember, cotangent cubed x is the same as writing it as cotangent of x all cubed. It means the exact same thing. So we just used the inside part for our u and left the cubed. So now we do the antiderivative and get negative 1/4 u to the 4th plus c. So that's negative 1/4 cotangent of x to the 4th plus c. And you can write that 4th there, or if you prefer, you can write it there. So this is one way to write the answer, and this is an equivalent way to write the answer. Okay, we're going to use u substitution again. U will be the inside, the x squared minus 5. Du will be 2x dx. Just a reminder before I go on, u is going to be something you find inside of a power, a radical, a trig function, or the denominator. That's where you want to look for your u's. So this is a perfect match, 2x dx, 2x dx, so no adjustment is necessary. We just end up with u cubed du. Antiderivative is u to the 4th, 1/4 u to the 4th plus c. So I get 1/4 x squared minus 5 to the 4th plus c. Remember, if I'm going too fast for you, you can always pause this or rewind and look at it again. 22. Another u sub problem. U is equal to tangent x. It's inside of a radical and it's in the denominator. Two reasons to pick it. Another is the derivative is secant squared, which is a perfect match for the top part. So your du goes on top because that's where secant squared is. Your u goes inside the square root. This can also be written as u to the negative 1/2 du because the square root is to the 1/2. If you bring it up top, it's negative 1/2. So then I add 1 to the exponent, divide by that number, and I get 2 times tangent of x to the 1/2 plus c. Keep in mind that can be written a couple different other ways. You can put the 1/2 in the middle, or you can even change that 1/2 back to a square root. Any of those are equivalent. 23. This is not a u sub problem. The red flag here should be that there's just a single term on the bottom that we're going to be able to simplify with. Because if we rewrite this as x to the 3/2, which is the same thing as the square root of x cubed, then we can split this into two pieces and then just simplify. U sub won't be necessary. So when we simplify this, the first term I'm really just bringing it up to making it a negative 3/2 exponent. And the second one, they cancel out, just leaving the 3. So now I add 1 to the exponent, divide by that number, and I'm going to end up with negative 16 x to the negative 1/2 minus 3x plus c. Okay, just a couple more and we'll be done. 24. This is another u sub problem. We want to choose x squared minus 2x. It's in the denominator and it's in a power. The derivative is 2x minus 2, which isn't an exact match for the top, but we notice if we divide by 2, then it will be. So if I divide everything by 2, I get 1/2 du equals x minus 1, and then it matches the top. So I end up with a 1/2 out front, du on top, because that's what it replaced, the x minus 1, and on the bottom I get a u squared. So I can rewrite that as 1/2 integral of u to the negative 2 du, then add 1 to the exponent, divide by that number, just makes it negative, and add plus c. So my final answer is negative 1/2 times x squared minus 2x to the negative 1 plus c. Now I am very okay with that answer. You can leave it that way. Just keep in mind it would be the same thing as moving it back to the bottom and writing it this way. That would be an equivalent way to write the same thing. Two more. On 25, we're still using more u sub. U is equal to 2x minus 4. The du would just be 2 dx. Well, we don't have 2 dx, we have 1 dx, so we'll have to divide by 2. And we get 1/2 times the integral of du over the square root of u, or 1/2 u to the negative 1/2 du. So then I add 1 to the exponent, making it positive 1/2. Divide by that number, canceling them out. So I get 2x minus 4 to the 1/2 plus c, or square root of 2x minus 4 plus c. Those are both good ways to write that answer. And for the last problem, it's also u sub. U will be x to the 4th minus 3 because it's inside the power of 5. The derivative is 4x cubed. We don't have a 4, so we need to divide both sides by 4. We get 1/4 du equals x cubed dx. So that's 1/4 integral of u to the 5th du. So add 1 to the exponent, divide by that number. We get 1/24 times x to the 4th minus 3 raised to the 6th plus c. Good luck to everybody on the test. I'll see you then.